All right, so for this first section, we're going to be talking about what statistics is. This whole chapter will cover the idea of statistics. So statistics can be viewed as the science of doing stuff with data. And the stuff that we're doing is collecting, organizing, visualizing and summarizing, and analyzing data. So how to collect data, that's really important. You want to make sure you're collecting data in a way that makes sense for the problem that you're studying. So you want to make sure that you're collecting data in a non-biased way, so you're kind of getting a good picture of the problem that you're studying. Organizing data is making sure that once you have this data that you've collected, that it's in some sort of usable form. So once you've collected it, you need to organize it. After that, and this is what we're going to focus on for the first bit of this course, are visualizing and summarizing. Once you have this data organized, it's kind of not particularly nice to show people your data just as it is without doing some sort of graphing or summarizing of it. And that idea of visualizing and summarizing is called descriptive statistics. It's coming up with a good way of showing data in an encapsulated way so people can understand. And the other way is analyzing data. That's the other thing you can do with data, and that's kind of using past data to make predictions about the future. You'd see 1, 2, and 5, and also 3 and 4 in a dedicated statistics course. But for our purposes, we're going to focus on 3 and 4. It's the idea of encapsulating data so it's easier to understand. And the two ways that we're going to cover are via graphs, so taking the data and coming up with a nice visual way of describing it. And the other is these representative numbers. So let's say you're collecting data about heights of people or something. You wouldn't want to just list 50 heights in a news article or something. That would be really hard to parse what's going on. So maybe just 1 or 2 numbers that give you a feel for what the data looks like is good enough to get your point across. So these representative numbers we'll talk about, things like talking about the center of the data and how far the data is spread out. They come under representative numbers. And a little jargon to get through. Kind of whenever we start a new topic, we'll always start by talking about some terms, just so we have the same language to talk about these things. And the two most important are variables and data. So a variable is just a characteristic that varies from one object to another. For example, if your objects were people, maybe a variable that you'd want to measure is height. Height varies between 2 people, or maybe it's eye color. Eye color varies. It could be brown, it could be blue, it could be green, whatever. So it's anything that varies from one object to another. And data, they're the actual observations of that variable that you're making. So if your variable was, say, height, maybe one data element is your measurement of your height. So let's say for me, if I was the object and you were measuring the variable height for me, you would measure my height as 6 feet and no inches. So that is the data that goes along with the variable height for the object, me. So that's an example of variable and data. Now there's 2 types of variables that we're going to come across, and we're going to treat them a little bit differently. Different graphs will be appropriate for different types of variables. And they are categorical and numerical. And I guess I'll talk about numerical first. There are things you can count or measure. You can measure somebody's height. You can count how many siblings they have. You can calculate and therefore count the percentage of students that are from Manitoba. Or maybe another thing is time. So let's say another one would be time to get to class from home, say. There's another example of a numerical variable, because that is something you can measure or count. We can measure with our watch how long it takes to get from class to home. And anything you kind of can't measure or count, so that they're things that just have more qualitative explanations, they are categorical, so they're labels or categories. Your favorite color, well, that's things like red, blue, white, black. They're not really, it's nothing you can measure or count, so it's just categories. So that's a category, favorite color, or maybe employment status. Full-time employed, part-time employed, unemployed, retired, they are all categories. Jersey number, even though they're numbers, you could think, well, they're numbers, so it's going to be numerical. But no, jersey numbers, be careful here, because you're not counting or measuring anything. They are just a label that goes to a particular player on, say, a hockey team. You could imagine nothing would really change if you replaced jersey numbers with jersey letters. Maybe, say, Wayne Gretzky, instead of having the number 99 on his back, might have the letter Z instead. That's fine. That kind of doesn't change anything. It would operate in the same way. So jersey numbers really are labels more than they are counts or observations, so we think of them as categorical data.